All right, today we're looking at tangents. So when we're talking about tangent, this is a line that touches a circle at only one point. So this would be the tangent. A, B, it's touching the circle only at one point here. Center is M, M to the point T, that would make it the radius. All right, so if a radius is drawn to the point where the tangent touches the circle, then the angle formed is 90 degrees. So radius goes to the tangent line, it makes this 90-degree angle. So we can say here that the radius, MT, is perpendicular to the tangent, AB, making that 90-degree angle. All right, so again here, a line that intersects a circle at only one point is a tangent to the circle. The point where the tangent intersects the circle, that's called the point of tangency, shown right here. So here, line AB is a tangent to the circle with center O. And point P here is the point of tangency. And that property or rule is called the tangent radius property. So like we just saw before, a tangent to a circle is perpendicular to the radius at the point of tangency, therefore making that 90-degree angle. All right, so here angle APO is 90 degrees, as well as BPO will also be 90 degrees there as well. All right, so knowing that information with tangents, we can figure out angles. So in this example, point O is the center of a circle, and AB is a tangent to the circle. All right, so in triangle OAB, angle AOB here is 63 degrees. Figure out the measure of OBA. So we're trying to figure out this angle here is the one we're trying to figure out. But we know that from our rule there that we talked about with tangent lines is that this here is going to be a 90-degree angle. All right, so now that you know two angles, 63 and 90 degrees, you can figure out that angle. Okay, so you just take 180 degrees, subtract 90, subtract 63, and we get 27 degrees. All right, so this angle here, OBA, is equal to 27 degrees. All right, in this example, point O, again, is the center of the circle. CD is the tangent, and we're told it's 15 centimeters. OD, we're told, is 20 centimeters. All right, we have to figure out the radius, O to C. All right, so again, we know the tangent and the radius here are going to make a 90-degree angle here. So we have a right-angled triangle. We can use the Pythagorean theorem to calculate OC. We already have two measurements, 15 centimeters and 20 centimeters. So we're looking for this leg. We have the hypotenuse and one leg, so we just have to calculate O to C. All right, so 20 squared minus 15 squared gives us 175. Take the square root of that, and we get 13.23. All right, rounded to the nearest tenth, it's 13.2 centimeters long. All right, so for this example, we're trying to calculate side x. We know from here to here is 18 centimeters long. It's a tangent line. So therefore, from here to here, this is going to make a 90-degree angle here at the point of tangency. We need to figure out x here. So we have made a right angled triangle, and we're trying to figure out the hypotenuse. All right, keep in mind here that the diameter is 30 centimeters, so therefore the radius is 15 centimeters. All right, so basically from here to here is 15 centimeters. I'll just make a note of that here, 15 centimeters. All right, so now we can use our Pythagorean theorem to solve for this. So a squared plus b squared equals c squared. So 15 squared plus 18 squared will give us our hypotenuse, or their c squared. So we just put that into our calculator. Just gonna put that into the calculator. So 15 squared plus 18 squared, that gives me 549. Remember to take the square root next. And that gives me 23.43. So 23.43 centimeters is x. All right, so in this example, xy is tangent to a circle, to this circle. So xy is the tangent line. This is the radius. So therefore, this here is going to be the 90-degree angle. We have to figure out the two interior angles. So here and here is what we're trying to find out. So we know this is 90. So we know together 5x plus 3 plus x plus 9 has to equal to 90 degrees to give us a total of 180 degrees for a triangle. So just over here, so we know that 5x plus 3 plus x plus 9 has to equal to 90 degrees. All right, so this is a little bit of a review of polynomials. All right, so we can open up the brackets because it is addition. We're not changing any signs. So this becomes 5x plus 3 plus x plus 9 is equal to 90. Next, we can collect our like terms. So we can collect 5x and x together. 5x plus x, that gives me 6x. And then we can collect the 3 and the 9. 3 plus 9 is 12, so now we have 6x plus 12 is equal to 90. And now we can solve like normal. Subtract 12 on both sides. That gives me 6x is equal to 78. Divide by 6 on both sides, and that gives me x is equal to 13. All right, so now we know x is equal to 13. Put them into each of those equations to figure out each angle. So for this angle, it'll be 5 times 13 plus 3 to give me 68 degrees. And then here, that angle is x plus 9, so 13 plus 9, which gives me 22 degrees. All right, so we've solved now for both those angles. And you can double check that. 68 plus 22 plus 90 has to equal to 180 degrees.